Before we get into the substance, if you care about serious history, real-world survival knowledge, and lessons pulled straight from the past, make sure you subscribe to the Prepper Historian now and share this with someone who still thinks modern materials automatically mean better performance. What you're about to hear isn't trivia. It's a forgotten system that kept armies alive, weapons functioning, and gear dry long before plastic dominated the world. This story matters because it cuts straight through a modern myth. We're told waterproofing only truly arrived with polymers, synthetic membranes, and factory-sealed plastics. World War II proves otherwise. In fact, some wartime waterproofing methods outperformed early plastics in durability, repairability, and long-term field use. Soldiers trusted them with their lives, and for good reason. Why wartime waterproofing had to work every single time? World War II equipment faced relentless abuse. Rain, snow, mud, salt water, tropical humidity, and freezing temperatures destroyed anything poorly designed. A failed waterproofing system didn't just mean discomfort. It meant ruined maps, jammed rifles, soaked boots leading to trench foot, and rations turning to waste. Militaries needed solutions that worked without factories, power tools, or resupply chains. That pressure forced innovation grounded in materials science rather than convenience. Plastic existed, but it was brittle, scarce, and degraded under UV exposure and cold. Instead, armies leaned on layered textiles, natural oils, waxes, and resins refined over centuries, then industrialized for war. Wax canvas was, honestly, the backbone of Allied waterproofing. The most important World War II waterproofing material wasn't rubber or plastic, you know. It was wax canvas, cotton duck fabric saturated with a blend of paraffin wax, beeswax, and sometimes even a bit of linseed oil, created a flexible, breathable, water-shedding barrier. Unlike plastic sheeting, wax canvas didn't crack in cold weather. And unlike rubberized fabrics, it could actually be repaired right there in the field with a bit of heat and some spare wax. British and American forces used waxed canvas for, well, just about everything. Packs, ponchos, map cases, ammunition bandoliers, and vehicle covers. The fabric swelled slightly when wet, tightening the weave and, remarkably, improving water resistance. That self-sealing behaviour is something plastic still struggles to replicate, unless you use those complicated membranes. Modern application is, frankly, pretty straightforward. Heavy cotton canvas, paraffin wax and beeswax melted together can be brushed into fabric, then heat set with a heat gun or just a bit of sun exposure. A modern prepper can waterproof packs, tool rolls or tarp shelters using exactly the same method, gaining a level of durability that plastic tarps, well, rarely offer. Oil-treated leather kept soldiers mobile in the worst conditions. Footwear was another battlefield where World War II materials outperformed plastic, you know. Leather boots were treated with dubbin, a paste made from tallow, oils and waxes. This treatment didn't just repel water. It conditioned leather, prevented cracking, and allowed boots to flex naturally in freezing temperatures. Plastic-coated boots, introduced later, often trapped moisture inside, leading to rot and frostbite. World War II treated leather breathed while shedding water externally. Soldiers reapplied dubbin regularly, often warming it near a fire and working it into seams by hand. Today, the same method applies to leather gloves, boots, tool sheaths, and belts. Regular oil and wax treatment extends lifespan dramatically and maintains flexibility across temperature extremes. This is waterproofing that improves with maintenance rather than degrading. Shellac and resin coatings protected wood and metal without sealing them dead. Firearms, crates and vehicle components faced moisture constantly. The solution wasn't plastic wrap, you know. It was shellac and resin-based coatings. Shellac, derived from elac resin, created a moisture-resistant seal while remaining repairable. Unlike modern polymer coatings, shellac could be stripped and reapplied without specialized chemicals. Crates carrying ammunition and medical supplies were often shellacked internally. Wood stocks on rifles used oil finishes rather than plastic coatings, allowing water resistance without trapping moisture that could warp wood. For modern use, shellac remains valuable for sealing wood tool handles, storage boxes, and even paper-based maps when diluted properly. Resin-based finishes derived from pine tar still outperform many synthetic sealants for outdoor wood exposed to fluctuating humidity. Grease was honestly the unsung hero of metal waterproofing. During the Second World War, armies relied heavily on grease as a moisture barrier. Cosmoline, which is a petroleum-based rust preventative, was used to coat weapons, machinery and spare parts for long-term storage. It was thick, messy and, well, incredibly effective. Parts preserved with Cosmoline have actually been recovered decades later in usable condition. You know, plastic coatings can crack or peel, which allows corrosion to creep in underneath. Grease, on the other hand, displaces water completely, and really it can be reapplied endlessly. Soldiers learned how to strip and reapply it quickly, using heat and solvents that were available right there in the field. For preparedness today, heavy grease still remains one of the best ways to store tools, firearms and spare metal parts for the long term. It's not elegant, but it works, and importantly, it's reversible. Now, why did these traditional methods actually outperform early plastics when put to the test in real-world conditions? Well, plastic certainly brought some convenience, but it just couldn't hold up under stress. It would crack when it got cold, melt if it was too close to heat. And, you know, it would just degrade if left out in the sunlight for too long. During the Second World War, waterproofing depended on materials that, well, aged slowly, could be repaired just about anywhere, and crucially, didn't fail all at once. Wax, for example, would just wear down bit by bit. Leather? It would dry out slowly before it ever cracked, and grease would simply thin out before it disappeared entirely. These kinds of warning signs, they really mattered when you were in a survival situation. Most importantly, these systems were modular. A soldier didn't need to replace an entire item. He repaired it. That philosophy is nearly extinct today, but honestly it remains critical for anyone planning beyond short-term convenience. So, how can modern survivalists apply this knowledge today? Well, start by replacing plastic dependence where durability matters most. Waxed canvas for bags and covers, oil-treated leather for wear items, And of course, grease and shellac for storage and tools. Learn the maintenance cycle, because you know WWII waterproofing was never about set and forget. It was always about upkeep, inspection, and understanding your materials. This knowledge isn't just nostalgia. It's practical engineering, refined under pressure. If this kind of deep material-level history matters to you, subscribe to The Prepper Historian, share this with a fellow history buff or survivalist, and keep these lessons alive. The past still outperforms the present when we actually understand it.